Now we are going to compare two different values from two different experiments. That is nothing but de Broglie wavelength of electron. The de Broglie wavelength of electron, its value that can be obtained from two different experiments. One is from Davisson and Germer experiment that is given in your textbook, and its formula is also given. Therefrom we are able to calculate the de Broglie wavelength of electron. The same answer that can be obtained from Bragg's equation, that is from Bragg's law, but this is not given. But at the end of the essay, the answer is given. I will explain how the values can be calculated from two different methods, two different experiments, how both are equal, how they can be compared. I will explain one by one. Here the thing is, you have to imagine the crystal, nickel crystal. This nickel crystal is going to diffract the electron beam. Here you have to imagine that this is the electron beam that is made to incident on the nickel crystal. After incidence, what happens? Due to diffraction and scattering, the electron beam gets scattered and diffracted. These two electron beam, both of them will interfere with one another and they will act as a coherent source. After interference, they will cause the constructive interference and they will produce the maximum intensity X-ray at the scattering angle of 50 degree. Are you clear? So, to get the maximum intensity X-ray, a potential difference must be applied in between the cathode and anode in the Davisson and Germer experiment setup. There, at the voltage of 54 volt, at an angle of scattering angle of 50 degree, this constructive interference happens. Now you know the value of scattering angle theta, which is equal to 50 degree, the glare at the accelerating potential of 54 volt. Now we know the value of V and theta. Are you clear? And these two, they are creating the maximum intensity X-ray. That's why this order of the X-rays, that constructive interference order can be taken as n is equal to 1. Are you clear? Here, this is the potential difference that one was applied in between cathode and anode, and substitute the value of V in the formula. So what is the formula to calculate de Broglie wavelength of electron? Lambda is equal to 12.27 Armstrong divided by square root of V. There you substitute the 54 volt. After calculation, square root of 54 is equivalent to 7.34. In the formula itself, Armstrong is there. Therefrom, we are able to calculate the de Broglie wavelength of electron as 1.67 Armstrong. It shows that the wavelength of the electron, when it is moving in the form of wave, matter wave, is equal to 1.67 Armstrong. Now the thing is, that answer to be compared with which one? The answer obtained in Bragg's equation. This is the equation called Bragg's equation. Here pi is called as glancing angle. That is very important. The angle which is taken into the consideration in the case of Davisson and Germer experiment is, what is it? Scattering angle. But here in the case of Bragg's equation, this pi is called, what is this? Glancing angle. How to calculate the glancing angle? Here pi is called glancing angle. Are you clear? Now from scattering angle, how to calculate the scattering angle, glancing angle? From scattering angle, how to calculate the which one? Glancing angle. Look at the formula. Total angle is 180. 180 minus 2 pi is equal to theta. Very simple formula. So here 180 minus 2. Is it clear? Here 180 is already here. This 50 is already found out, scattering angle. If the 50 is brought in this side, that one becomes 180 minus 50, which is equal to plus 2 pi. Plus 2 pi can be brought in this side. 2 pi is equal to 180 minus 50 is equal to 130, and 2 pi is equal to 130. Pi is equal to 130 divided by 2. Its value is 65. So glancing angle here, the glancing angle is nothing but 65. So what is glancing angle? The angle between the incident electron beam and the first planar surface is called, what is this? Glancing angle. So now we have found out the value of glancing angle. In Bragg's equation, glancing angle must be substituted, not this theta. Are you clear? So 2 into What is d? D is nothing but distance between these two planes is called, what is this? Interplanar spacing. This is called interplanar spacing. That interplanar spacing in the case of nickel is 0.91 Armstrong. Substitute here and we know the value of which one? Glancing angle, that is nothing but sine 65. Order of the constructive interference pattern is n is equal to 1 and then lambda is here. Interchange the formula, 2 into 0.91 Armstrong sine 65 to be substituted. Sine 65 value is 0.906 and multiply everything. Don't convert Armstrong. So finally after calculation you will be getting the answer is 1.65 Armstrong. So this is the de Broglie wavelength obtained from which one? Bragg's equation. Are you clear? So the answer obtained from Davisson and Germer experiment, that one is verified with the help of Bragg's equation. Very interesting one. The main important part in the thing is which one? How to calculate the glancing angle from scattering angle. That is very important. Okay. Thank you. Both the two answers obtained from two different methods are same. So the answer which is obtained from Davisson and Germer experiment is proved and it is verified by the answer obtained from Bragg's equation. Okay.